Turbidimetry or turbidimetric analysis is actually a qualitative test on the amounts of protein by actually testing the turbidity of a solution. It uses an ionic organic ions such as trichloroacetic acid and sulfosalicylic acid to precipitate proteins and thus makes the solution turbid. Thus, protein concentration is measured by the degree of turbidity. The higher the protein concentration, the higher the turbidity. Well, how to measure turbidity, you ask? It is done by measuring the loss of intensity of transmitted light due to scattering of particles suspended in the protein solution. This is known as spectrophotometry. What we are actually going to do is to test the protein concentration of various everyday food, specifically milk, soy milk, raw potato, bread, egg white, and lastly potato chip, using the turbidimetric method. However, we will not do the spectrophotometry part and will only describe the data in qualitative basis. This experiment is actually simple and we are not going to need that much of equipment. Here are the things that we are going to need: graduated cylinder, some cloth, 250 to 500 ml beakers, balance, test tube rock, spatula, pasture pipette, a hot plate, 10 ml test tubes, and lastly, steering rod. We're going to use some anionic organic compounds in this experiment, and in this case, we will use trichloroacetic acid and sulfosalicylic acid. And also, we're also going to use magnesium sulfate and vinegar in precipitation of our proteins. So, the mechanism of this activity is actually pretty simple. Organic acids such as trichloroacetic acid and sulfosalicylic acid are negatively charged. They bind to positively charged surfaces of proteins to form neutral salts. These protein surfaces are actually side chains of amino acids, which in normal condition binds with H2O molecules. This binding of negatively charged acid and positively charged side chain of amino acid will actually create a nonpolar side of the amino acid. And by the law of hydrophobic interaction, proteins will form complexes or micelles due to the formation of insoluble parts of the protein. Thus, protein precipitation will occur, and voila! Turbidity. This process is called salting in, which only works in acidic solution. However, if we wanted to do this, we need to isolate the proteins first. Isolation of protein can be done by the same mechanism of salting in, by denaturation and renaturation procedure. This is done by heat or other organic solvents. We can start our procedure by preparation. First is for us to prepare for our milk. We prepared 120 ml of milk in this case. In our isolation, we need to heat it up to 21 degrees Celsius only. This partially unwinds our tertiary structure. Next is we need to add 2 ml of vinegar to the heated milk. Acids such as vinegars further denatures our milk. And it is also a requirement that our solution must be acidic in order for the salting in to occur. We allowed our milk to rest for 5 minutes. Notice the white precipitates? This is actually an indication that our denaturation-renaturation process is successful. Majority of the composition of the milk is actually casein. It is a protein. By denaturation of the casein, we have exposed its secondary structure. By adding an acidic solution, casein will attempt to renaturate. This entire process is called curdling, which has the same mechanism as salting in. Next thing that we need to do is to recover the curds. Our cloth will do the trick. We mounted our cloth on the top of the beaker and filtrated our curd. The next step for us is to prepare for our soy milk. Similarly, we heated our 120 ml beaker with the milk in it, but this time, we allowed it to boil. Our organic reagent would be magnesium sulfate in this case, in order to precipitate the protein. 1.6 grams of magnesium sulfate is used. Magnesium sulfate is highly soluble in water, and either magnesium or sulfate interacts with the positive or negatively charged amino acids, creating neutral sites. By renaturation, as you can see, we have isolated our curds. By stirring continuously, more and more curds are produced. We also use cloth to precipitate the curds. Other than these two, we also need to prepare bread, potato chip, egg, and raw potato. However, in this case, they are all solid. So isolation from H2O is not really needed. Now that we are prepared, it is time for the testing proper. So we had prepared our trichloroacetic acid and sulfur salicylic acid beforehand and placed them in separate test tubes. We divided each of our sample into two, test tube A and test tube B. Test tube A will house the trichloroacetic acid test and test tube B will house the sulfur salicylic acid test. First, we started testing the milk culls. We added 5 ml of water each into the test tubes. Then for test tube A, we added 5 drops of trichloroacetic acid and 5 drops of sulfur salicylic acid in test tube B. So our observation is a slight turbidity in the milk of test tube A and almost clear solution on test tube B. These two solutions have leftovers, as we can see that settled in the bottom. This is probably due to acid successfully reacted to organic acid dispersed in the medium. In case that no product is present, no turbidity must have been occurred. Now, let's test for the soy milk. Perform the same procedure and obtain almost clear solution with no turbidity and a lot of leftovers with test tube A. Test tube B, however, had intense turbidity with some slight leftovers. Salicylic acid really favors soy milk than trichloroacetic acid. In our two variants of milk, it is possible that soy milk have more protein concentration than the low-fat milk. Proceeded with the experiment in testing the egg white. Egg white showed strong turbidity in both reagents, with some leftovers. Trichloroacetic acid, however, are stronger in affinity than the test tube B, as to compare the turbidity. Strong precipitation is probably due to the presence of protein albumin on the egg white. However, it is pale in comparison with the two milk variants. Potato chips possesses a slight turbidity on both test tubes, weaker than the albumin and the two milk variants. Being synthetic and not pure on potato content, chips such as this will read low protein concentration. However, this is kinda ironic on the results of raw potato. Presents with almost low precipitate on both tests, except for some color change on test tube A. This further implies the importance of denaturation on protein testing, which is also equally important in cooking and providing easier access to food nutrients. Overall, the two milk variants possesses the most turbidity, and raw potato and bread reveals the least. Denaturation is a major factor in all of these results, and actually it may compromise the results if we haven't done so.